Good day to everyone who's joining us for another session of the AWP Community of Practice webinar series. Really appreciate you joining us today. We're joined by O3 Solutions. O3 Solutions, as you may know, is a provider of technology and implementation support expertise around advanced work packaging for industrial construction projects. O3 Solutions recently presented at the AWP Conference this past October on the topic of AWP and engineering, which is a critical topic that is definitely in need of further development. And we'll be actually welcoming O3 back to the webinar series here, ideally before the end of the year, to do a replay and a live Q&A of that excellent session that they presented at the conference. Today, we're actually going to be talking, we're hearing from Josh Girvin and Andrew Foy on the topic of technology that supports AWP maturity in engineering and the 4 levels of AWP maturity in engineering. So before we get started, I just want to encourage you to join us at slido.com at any point during the session using event code O3ENG, or just use your smartphone to scan the QR code that you see on screen right now. And you'll be able to send your questions and comments directly to the presenters, and we'll be addressing those during the Q&A, the dedicated Q&A time here at the back end of the session. So again, thanks for joining. We'll have a couple more sessions planned for you in December before we close out the year. So watch your inbox for information about that. Otherwise, again, thanks in advance to O3 for presenting this session today. Thank you for joining, and I'll hand it over to Josh to kick us off.
Great. Thank you, Steve, for that introduction. I am Josh Girvin. I'm the CEO of O3 and very involved in the Construction Industry Institute Advanced Work Packaging CBA. And most important, I've co-chairs and founding the new joint working group around engineering. So for folks that are interested in this topic and want to be part of the conversation going forward around the levels of AWP maturity in engineering and how to best grow adoption of AWP in engineering, please reach out to me, Josh at o3.solutions, and would love to have you join that joint working group. Also with me today is Andrew Foy.
Good morning, everyone. My name is Andrew Foy. I'm the Director of AWP and Construction Excellence for O3. I've been in industrial construction for nearly 20 years now, the last 6 or 7 of which have been in a dedicated AWP role, setting up AWP for various clients across North America. I'm also heavily involved in CII, currently co-chairing the Performance and Benchmarking Subcommittee. Thanks, Josh.
Absolutely. So our agenda for today, we're going to talk about a couple of things. We went through the speakers. We'll do a safety moment. We'll briefly talk about who O3 is, and then we'll jump really into the meat of the conversation today, which is about AWP and engineering. We'll start by framing up that conversation about how AWP forgot about engineering, how we see opportunity there, the levels of AWP maturity within engineering, and then some key takeaways, a call to action to join the CII team, and then a live Q&A session. So please, again, if you have questions that you come up with during this, join in Slido. There should be a link in the chat as well, so that you can join and capture those questions as we go. First safety moment, just something to keep in mind around the time changes, so the fall back and the spring forward. There are an increase in traffic incidents and deaths around these times because of the shorter days, as well as the change in schedules. People are more groggy in the morning if they've lost time. So it's something to keep in mind and to drive extra safe around these time periods. Make sure that you are extra aware and keep your vehicle clean and up to par to be extra safe around these times. So with that safety moment, we'll move into a little bit about who O3 is. O3 is a modern web-based platform that's built specifically around advanced work packaging and agile best practices for the industrial construction space. So not a technology that was built pre-AWP and then wants to convert to being an AWP tool built from the ground up to support these practices across the entire project lifecycle. And in terms of the solution set, that we do have a solution set that covers across all the phases of the project, from the front end planning with on plan all the way through commissioning and startup with on start. So it is a solution that covers the entire project lifecycle, but today we are going to be focusing mostly on design, which is around AWP and detailed design, and then some about on build, which is really about work phase planning, or AWP during construction execution. So those are the two areas of technology that you'll hear about most today. So first, we want to talk a little bit about how we got here. Why are we having this conversation about AWP maturity levels in engineering? And really, this started with a blog post that I wrote, and Andrew and I collaborated on this blog post about how AWP has forgotten about engineering, and in fact how CII hasn't gone as far with AWP definition in engineering, and there's an opportunity for us to extend that to drive more use of AWP in engineering. So we noticed that AWP is not being adopted as much in engineering as it is in construction execution, and asked ourselves, why is that? And fundamentally, the conclusion that we came to is that AWP is designed to optimize construction. And so engineering's role within AWP is really about supporting construction, making sure construction has the information it needs when it needs it, making sure that construction can be productive in the field. That's really what AWP focuses on from an engineering perspective. And so we asked the question, is there an opportunity for engineering to leverage AWP to benefit engineering directly? And that's what's led to this conversation about the levels of maturity and how we think that engineering can be advanced. And so we've been working with a number of EP firms that are AWP mature to help advance this forward. And now we're taking it to CII as an industry to help move this forward. So with that, I'm going to turn it over to Andrew to talk a little bit about the 4 levels of AWP maturity in engineering. Andrew?
Excellent. Thank you very much for that setup, Josh. Yeah, so like Josh said, we're going to look at the 4 levels of AWP maturity. So in a recent presentation, the one that Steve alluded to at the AWP conference, we outlined what these 4 levels of AWP maturity and how they relate specifically to engineering. It was used to highlight that a lot of engineering companies are at different points on their AWP journey. Some are stuck in their ways at what we call level 0, keeping everything status quo and viewing AWP as an impediment rather than a benefit. These companies find every reason possible to avoid doing something new and can't see any advantage to it expanding outside their current processes. On the next rung up the ladder at level 1, some engineering contractors are recognizing the need to support the project by implementing steps to help with work phase planning. These companies know that their work is used by construction and are starting to see the benefit to the overall project that can be realized by aligning engineering output with construction needs. Next, on the next rung up the ladder in AWP maturity at level 2, these are the companies that are starting to embrace AWP concepts, not just for the work in the field, but also for their own scope. These far-sighted contractors are seeing that AWP is here to stay and are adapting their processes not only to support construction and the project as a whole, but also to find ways to bring AWP value to engineering. And then lastly, at the top level, level 3, AWP maturity, this is where AWP is really creating benefit directly for the engineering contractors. AWP benefit at this level is well known and understood. Engineering processes are being adapted to align to overall project goals while still maintaining engineering efficiency, which is always one of the pushbacks we hear. AWP is providing benefit to engineering regardless of whether or not work phase planning is being used. This is the zenith of AWP for engineering and frankly should be the goal for all engineering contractors. So in this presentation, we're going to explore the details of each layer more closely. So first up, we're looking at level 0, what we're calling the status quo in engineering. So in this stage, what we have is a typical old school process. We've got engineering planning, engineering prioritizing their work, creating a bunch of drawings, and then we have this terrible block between there and the field. And this is where things fall apart. Construction planning is ignored, and frankly, engineering executes their scope in the most efficient way for engineering. It's optimized for engineers with little thought for a site installation. There's no construction planning during the engineering stages. Construction is typically forced to start as soon as some drawings are ready, regardless of whether they're meaningful or whether continuous work can be available to support field crews. And construction work, as a result, is often paused or reprioritized based on the availability of drawings and materials, which of course causes delays and inefficiencies. So looking at the investment for this stage, this is very much the status quo level of investment. So during the engineering phase, you'll see there is no construction presence. In the construction phase, you just have the construction people turning up when they start to get drawings released. So this is the construction manager, the discipline superintendents, and if they are doing work phase planning, they'll have the work phase plans. On the technology side, the project is still probably using something like P6 for a schedule, but typically you're going to get disparate schedules between engineering and construction. And you see a lot of Excel for things like materials management, drawing management, and reporting. And that's going to be the way that information is shared from one to the other. So what are the outcomes of doing this? Unfortunately, we're going to see several bad outcomes. Construction starts too soon without sufficient backlog to maintain field installation. We always have a rush to get to the field. Installation activities are constantly being rearranged to support available scope, leading to inefficiencies. We keep stumbling across things that we don't have, and then finding we have to switch our plan and go and do something else. Partly because of that, schedule dates can't be maintained. The deliverables aren't there to support them. We don't know what's coming at us, so how are we supposed to plan a good, effective construction schedule? And then safety and quality suffer from poorly planned and constantly changing work execution. A lot of times you'll see with safety evaluations, when you go and do a root cause analysis, one of the things that's changed is the plan changed, so we weren't sure what to do.
So from a technology perspective, what we see a lot in this status quo of AWP maturity within engineering, so keep in mind we're talking about AWP maturity within engineering, we see a lot of spreadsheets. So there's a lot of rear-facing data, makes it harder for issues to be recognized and mitigate the impacts of those issues, and the visibility as an owner or owner's rep is significantly reduced and becomes this kind of rear-facing periodic reporting. That said, what we do also see is the ability to use work phase planning within this level. So even if you don't have engineering actively participating and supporting the work phase planning process, even if drawings are just being thrown over the fence, you can use O3 to plan that work. So you can make the best of that. Non-graphical planning, O3 gets in and allows you to support that. And if you have support and more engineering data, you can consume that as well. So there is the ability to use work phase planning at this level, but obviously we prefer to see it where you have engineering actually supporting that, which is what we call level 1 maturity of AWP within engineering, where engineering is actually supporting the work phase planning process. And Andrew?
Yeah, so at this stage, we're starting to see some meaningful change. So we're still seeing the engineering planning and the drawings being produced, but we're starting to see some construction information. We're starting to see constructability reviews. Construction is starting to have a voice in the room. So engineering is still performing work in the most efficient way for themselves, and they get some small amount of input from construction. These constructability reviews are used to provide a limited exposure to construction concerns and priorities for early planning. But we are also starting to see at this level a greater focus on the engineering data needed to support efficient planning and field execution. So from an investment standpoint, this is where things are starting to change. So during the engineering phases, you might get a construction manager or one or two or a few discipline superintendents in the engineer's office during the engineering stages, starting to apply some of that constructability. And that constructability is always going to be dependent in terms of its value on how early that stage is. On the technology side, again, chances are you're still using P6. You're getting more and more detailed, but still Excel reports. You're starting to look at a 3D model. You're starting to get a 3D model that's not just for the engineers, but something that can be of benefit to construction. And we're starting to get more integrated and more database-centric document management and materials management where that information can be shared. So what does this do to us in terms of outcomes? We're seeing a slight improvement in early construction planning by the use of constructability reviews. At least construction is being brought to the table. We're getting enhanced data integrity and reduction in human error by construction being able to use the engineering data. It doesn't have to be somebody sitting in the field typing it in and making mistakes transposing that data. This is also going to be a very, very important factor in making workplace planning faster and more efficient. We don't need as many planners. We have a reduced risk of those transposition errors. It's going to make the process of doing workplace planning much more viable. We're also going to look at maximization of that 3D model where available for use as a virtual construction model in workplace planning. That graphical, visual aspect for construction planning is a very, very powerful process. But on the downside, engineering is still sequenced to support engineering. It's not a construction sequence at this stage, so we're still seeing those efficiency losses in the field. So first up on the technology side, this constructability review. The constructability review is largely going to be focused on taking that 3D model and using it as an early ability to visualize the scope of work. You can start looking at site access. Do we have what we need to get in here? What are the spatial constraints? We can start looking at checking the model to see what we can understand in terms of modularization and prefabrication opportunities. Do we have areas where we can pull work from the field and put it into a prefab facility? Again, the old adage about the best hour you spend at site is the one you don't need to spend at site. And we can look at things like work area density, so we can start to see where we're putting all of our people and seeing if we're stacking a bunch of different trades all in the same area. So that graphical ability to use a 3D model for that constructability review is very, very powerful.
The other key part at this level is the consumption of that engineering data. So the ability to not just have a model that's useful to engineers, but then actually moving that into a virtual construction model. So you're consuming fabrication data and engineering list information, technical lists and schedules. You have this additional attribution in the 3D model, the ability to consume all of that data in together, engineering supporting and providing additional data, doing additional attribution. And so then from a technology perspective, it's very important that you have the ability to consume that data. So you have the ability to consume files from the fabrication. You have the ability to configure the solution to consume data from different engineering data sources and from different model types and different modeling solutions, authoring tools, the ability to consume additional materials management and expediting information, and that MDR data, the status and availability information of all those drawings, not just IFC drawings, but all the drawings, so you can have some visibility there. And then making sure you have the ability to manage that data, so know whether it's complete and whether it's fresh, and have the ability to drive activity to make sure that that data is kept fresh and complete and accurate within the system, so that you can have that automation, you can drive those benefits to the increased productivity and accuracy of your workplace planning process. So that takes us to level 2, which is engineering to support basic advanced work packaging. So this is not just, hey, let me help you with workplace planning. This is, I want to go a step further and support the project and the overall benefit to the project around leveraging advanced work packaging.
Yeah, and this is the next step up in the evolution. And the important first part here is the first chevron that you see is not engineering planning. Now, all of a sudden, we're talking about the first chevron that we see is path of construction. So we flip that mindset so that engineering deliverables are sequenced to support the path of construction. We're allowing for that efficient site execution by making sure that engineering executes in a way, or at least understands the way that construction is going to be working, and tries to align their processes and their release of information to support that. Engineering scope is then grouped into discrete packages, EWPs, each of which will have rules of credit, progress reporting, completion dates. Engineering becomes less of this black box that construction can't see into. We can start to see the granularity of information that's coming at us, the relationships between those packages, what we're going to get from engineering and when. And then we can also look at package constraints relating to engineering and procurement that will impact construction. These constraints can be identified, documented, and resolved, allowing for optimal site installation. So again, construction knows what's coming at them and when they're going to start to get information. From an investment side, what you're seeing here is, again, the same sort of level of construction manager, discipline superintendents during engineering, but we're taking that a step further now. Now we're bringing in our planning lead, we're bringing in our scheduler to make sure that that scheduler between engineering and construction makes sense, is integrated, and supports that path of construction. So the step up on the technology side is your P6 schedule suddenly becomes, instead of a disparate group of people trying to hand deliverable dates to each other, it becomes a truly integrated, logical, sequential EPC schedule. You're still using that 3D model, and you still want to be leveraging that information around things like document and materials management, but you can again take it a step further with digitization of other processes such as RFI management, get away from sending 100 emails a day to each other asking questions, and have a centralized database that everybody can have access to. So the outcomes at this stage, we're starting to see better and better results. We're seeing engineering sequenced to align with construction priorities to deliver meaningful work to construction. It's no longer a question of just, here's something, go do this. It's, here's what you want it first. Go and do this in the order that you want to do it. Engineering deliverables can be compiled into discrete packages. And the beauty of that is we can track them, we can schedule them, we can progress them, we can understand the interfaces between those packages and the construction packages. Engineering and procurement constraints are identified, documented, and assigned to an owner who is then in charge of making sure that they get resolved. So there's ownership of everything that's going to stop construction being able to do their job. The only downside with level 2 is we're still at that point where engineering is engaging in AWP for the benefit of other stakeholders. They're doing it sometimes because they're being told, sometimes because they understand the value to the project, but we're still not seeing it being done directly to the benefit of engineering themselves.
From a technology perspective, what you want to see here is the ability to support the path of construction. So the 3D model used as the basis for that installation sequence assessment. So actually using the 3D model and moving from a scheduling activity to a planning and sequencing activity. So leveraging the model and developing a plan and sequence as opposed to driving it from a schedule perspective. Doing 4D simulation of that so that you can validate that path of construction and then having the constructability review to actually move into a process of evaluating different installation plans and sequences. So this optioneering approach where now you're not only visualizing what you're going to do, but you're visualizing multiple options and then selecting the best option and then executing that option. And then addition to the path of construction, you also want to leverage engineering work packages. So having a tool that is purpose built around supporting AWP and engineering so it has true engineering work package support. So this is not just a tag or a collection of drawings the way you might see in some of the more antiquated legacy solutions. This is a true engineering work package. This is a real entity inside the solution that can go through a workflow. It has statuses and rules and progressing and rules of credit and approvals and alerts and notifications and reports and tracking and KPIs. It's a real actual tool, something that you manage, you create and manage inside of a solution. It's not just a tag on a bunch of documents that say, oh, those all belong to EWP 1, 2, 3. You need to really have a technology that treats the engineering work package as an actual package that's a core part of AWP. And then the same is true on the constraint management side, right? Constraint management is not a checklist inside of Excel. Do I have this? Do I have that? That's constraint identification. That doesn't move the ball forward. Constraint management is about having real entities inside the system where you say, this is a constraint, here's the owner, this is when it's due, having rules of credit and statuses and subtasks and approvals and a true ability to manage those constraints. It's not a checklist. It's something that enables proactive management and resolution and the ability to decentralize that. So you push out that constraint ownership to the other people on the project. A healthy project has lots and lots and lots of constraint owners inside of the solution, not one person quarterbacking that in the old kind of centralized mindset that we've seen in previous kind of non-AWP mature approaches to the solution. So you want to have this decentralized constraint management owned by everyone, and it's a true entity inside of your technology, not an afterthought checklist. That brings us to the next level of engineering maturity within AWP maturity within engineering, which is engineering to support full advanced work packaging, which really is engineering embracing advanced work packaging to drive value directly to engineering. So this is, I don't care what you're doing in field execution, I'm using AWP within engineering because that's the right solution for my organization. So this is the next level, the top tier, the gold standard of AWP maturity within engineering.
So at this stage, we're still seeing the first couple of things. We're still seeing path of construction. We're still talking about engineering work packages, but we're now taking that a step further to develop this in a way that engineering can get benefit out of it. So engineering is finally using AWP to benefit themselves directly. And they're doing this in a similar way to the way that construction does it with things like CWPs and IWPs. So you can take a granular breakdown of engineering scope into what we're referring to as design work packages, to give engineering the same control over that level of planning and work effort as the IWPs give to construction. We're creating and scoping vendor work packages to manage this critical deliverable. I mean, anyone who's ever been on the engineering side of a project, the vendor information is critical to this. We need to be able to see where it is, track the progress, track the completion against the target, understand what downstream packages that vendor work package is going to impact. And then we can start to look at agile management of things like constraints and tasks to improve the productivity and raise awareness of all the issues that are impacting engineering. So this gets away from the old, we've got a massive long engineering sort of list spreadsheet of things we need to figure out. You become a lot more agile in terms of understanding what's coming up, what do we need to deal with in the next couple of weeks, who owns this, what are the things that are going to bite us if we don't get them resolved right away. So I know that this concept of design work packages and vendor work packages is new to some people. So there's a brief sort of overview of what these are. These DWPs, the design work packages, those are subsets of the engineering work packages. And those are scope packages for a small team of engineers within a single discipline to be able to execute as a portion of that EWP. Again, much in the same way as the IWP would be a portion of the CWP. The VWPs represents the scope of work and the deliverables for a vendor. So you're going out to buy a major piece of equipment from a vendor, that can be a vendor work package. Now an EWP could have one or more VWPs, some of them will have none, but for the EWPs, especially things like mechanical equipment EWPs, you could have several different VWPs with several different vendors, and you can make sure to understand how to prioritize those vendor activities, not just treat it as the sort of first in, first out approach, but make sure that the vendor information you're getting in and the speed with which you're reviewing it and processing it reflects that path of construction, so we're getting it in the right order that we need it. In terms of the investment side of things, on the process and people side, we're not really seeing a major step up here. This is not going to be an addition of several bodies. What we're really talking about here is on the technology side, leveraging that technology, especially on the agile project management, and looking for a full lifecycle AWP software. So we're looking at an AWP tool, as Josh mentioned, specifically built for AWP, but more than that, specifically built to help AWP in engineering. It's not a bolt-on or an afterthought. This has been designed in consultation with AWP mature engineering firms to benefit them directly, not just have them considered as something after the fact to say, oh yeah, we should probably help you guys out too. The outcomes, green across the board. So we're looking at identification, assignment, status tracking, and resolution of engineering constraints. So we're not just talking about the constraints that engineering has on construction, we're talking about the constraints on engineering now, which is an important distinction. So we're starting to provide that benefit to engineering. One of those and most important constraints on engineering is that clear visibility into the vendor data status and the engineering packages that are impacted by it. If this is going to be late, what do I need to do about it? And also, which packages downstream is it going to impact? We can start to look at granular scope definition. We can manage those at the engineering work on a more granular level. And again, we can understand the interface between that granular packaging and how that's going to impact the field scope. So we can understand how that's being progressed. And then critical for, especially for the early phases, improve collaboration across stakeholders, getting everybody in the same tool. This is not sending emails to everybody which can get ignored. This is having a centralized space where everybody can use a single platform designed for that level of communication and involvement across stakeholders.
So from a technology perspective, in order to get into this level of AWP maturity, you have to work with an organization that supports that level of AWP maturity. O3 stands alone in this, that we've got 10 work package types out of the box. So, and our approach to advanced work packaging is that whenever we identify an additional perspective that can be packaged and managed within a package, you know, that's one that we want to incorporate within the tool. So scaffolding work packages, for example, startup work packages, turnover packages, labor work packages. So we have very AWP mature clients who are leveraging advanced work packaging across the entire project lifecycle. And here we're talking specifically about design work packages and vendor work packages, but it's important for folks to know that when O3 thinks about this from a design perspective, these are XWPs. And what we mean by that is that it doesn't matter what type of package it is. We've built the tool to have a set of engines. We have an approval engine, we have a constraint management engine, we've got a statusing engine, a workflow engine, a reporting and analytics engine, an alerts and notifications engine, and all of those are available with each of these package types. So as we build out additional package types, they are all treated as true entities inside the tool that can be statused and managed through a workflow. They can have progressing and rules of credit, alerts and notifications, all of these things that you have come to know and love about the way that O3 does installation work packages are also available on both the design work packages and those vendor work packages. And it's really valuable to take these, what are pretty wide open engineering work packages, these large level 3 schedule activities, and being able to break that work down into smaller discrete buckets gives you this better visibility. It gives you this better progressing, right? It moves you towards a meaningful progress. If half of my drawings are done in the EWP, what does that tell me? Can I work on anything? How does that align with what my construction requirements are? How does that align with getting done with specific components of that design piece? Giving additional visibility and discrete packaging of that is really valuable from a progressing and tracking perspective, and moving away from, hey, we're 99% complete on this EWP, but we can't do anything. And then the third piece here that's really important is the agile task management. So within the O3 tool, we have these team boards, and so you can view this in a Kanban view, you can view this in a list view or a calendar view or a Gantt view, but you can take all of these tasks and you can pull them onto boards. You can share those with different resources, so different teams can have different boards that they leverage, but it allows you to take all those tasks that today some of our clients have been leveraging tools, off-the-shelf tools for doing agile task management because they understand the value of having agile task management. What we've done is we've allowed them to now import that data and bring that into O3 and get rid of a tool that they're using for some task management, and then they have to go to O3 for other task management. Now they can do all of that task management in one place. So they can, and it's connected in, so it's not this disconnect where I'm using this, kind of generic agile task management tool that's not connected into my AWP. Now I can do all of that. I can do sprints, I can do Kanban approach, I can do list approach. There's all kinds of different methodologies that you can leverage using this, but now you've eliminated those additional tools and gotten that into one place, so you can have complete visibility. So we went through a lot of things today, talking about the different levels of AWP maturity, the investments and technology and outcomes associated with those. From a summary perspective, here you can see that all kind of in one view. Level 0 engineering maturity, the status quo. This is really where you see organizations doing work-based planning, but they're doing it with drawings that have been thrown over the fence. They're just receiving issued for construction drawings and then doing the best that they can with that to be efficient with the work that they can do. And so you can leverage work-based planning there. You can get better results than not using work-based planning, but obviously as we move up maturity levels, you get more value. So key technology there is typically non-graphical work-based planning, so you need a tool that really supports that. O3 was built from the ground up to not care whether you're doing graphical or non-graphical scoping. The underlying package management functionality is exactly the same, so there's very powerful non-graphical package scoping and management. And the outcome of that is you do get some improved field productivity. But as we move up to level 1 engineering to support work-based planning, now we're talking about the key investment being data requirements, and then technology perspectives, the ability to consume that data and leverage it. So you can have a well-attributed engineering model, you can have fabrication data, you can have other engineering data, you're pulling that in, you can manage that, and then leverage that for that automation in the work-based planning process. So if you have all this data connected inside the tool, now when I select a component to add to my installation work package, I automatically create my rules of credit, automatically create my quantities, and automatically create all of the information around this based off of the attributes of that component. So that attribution allows you to do that automation. That automation reduces effort, makes you work-based planners more efficient, and reduces errors. When you move up to level 2 engineering to support basic AWP, now you're introducing the engineering work packages and constraint management within engineering, and that requires an AWP solution. So you can't do that with just a work-based planning tool that thinks about EWPs as a collection of drawings or a tag on drawings. It has to be a true AWP tool that understands that engineering work packages themselves are a package that needs to be properly managed. And the outcome of that when you implement that is that enhanced construction and engineering alignment. So the visibility and alignment between those two, and making sure that engineering can better support construction. But then you get to that level 3, that's that full top tier gold standard engineering maturity for AWP. And that's when you're bringing in the design work packages, the vendor work packages, the agile project management. And in order to support that, you really need a purpose-built engineering AWP solution. You can't do this with Excel or a work-based planning tool that wasn't actually built to support this. So not just an AWP solution, but one that understands the value of driving AWP value directly to engineering. And then the outcome of that is that you do get that direct AWP benefit to engineering. So engineering itself gets a productivity increase as a result of the better structuring of these discrete packages and the more structured approach to constraint management. So you get that productivity increase. So that's a summary of the different levels of investment. Next, I want to talk about some of the key takeaways from this. So those key takeaways, we've grouped those into a couple of different ways of thinking about it. Andrew, if you could start with our key takeaways from an owner's perspective.
Certainly. So one of the most important things to understand within AWP in general is the owners need to own the AWP process. Now, there is a small carve out to that, which is if you are doing like an EPC contract and you're in charge of all the phases, you can have the greatest say over how it's done. But too often we see owners putting in place, we want to do AWP on this project with no consideration for what that means. They're not clear on how it's achieved, what their expectations are, who does what. So one of the key takeaways for any engineering or construction implementation of AWP is owner needs to be clear on what the requirements are. The same applies to data. There's a lot of data that's needed to support advanced work packaging. A lot of it already exists within engineering. We're not creating a massive cottage industry of new data requirements. We're just asking that those data requirements be organized and presented in such a way that we can use the information that engineering is already producing. But to make sure that we can do that, the owner, again, needs to have their hand on the tiller and say, these are the data requirements. Put them in the bid process. Acknowledge them as a deliverable. You'll have a lot better chance of enforcing it as a requirement if you've spelled it out in the contract before it's been signed. And then the other aspect from the owner standpoint is the collaboration. So typically, if you get a standard contracting environment where the owner has a relationship with the engineering contractor and the owner has a contractual relationship with the construction contractor, it can be sometimes hard to get that true collaboration between construction and engineering. Everything has to flow back through that contract holder being the owner. So the owner needs to make sure they are facilitating that collaboration, those discussions, and sometimes refereeing the discussions around the path of construction, for example. We also wanted to talk about setup. So when you're setting up a project, for example, the contracting issues. Engineering contracts, engineering contractors are incentivized to execute their work in the shortest time as possible and expend as few hours as possible. The problem is we're putting them in a box and saying you're only interested in engineering. So quite honestly, they are naturally going to do just what's required to fulfill the requirements of their scope of work. We need to take that contracting approach and create it as more of a project-wide mindset. So this is where we get into this concept of needing incentives. So you need to incentivize the performance that supports the project goals, not just the contractor's goals. So in terms of incentives, there's a couple of different ways you can look at it, especially when you're talking about an engineering contractor where work is typically done on a time and materials basis or a reimbursable basis, depending on your phraseology. So you can do it in what I would always describe as a sort of negative or limited way, where you can say some part of that contractor's fee is at risk or held back pending successful execution of AWP, the engineering deliverables, getting our EWPs on time, getting our information from engineering in the sequence that we agreed. Make sure they have some skin in the game. And that's the way that certainly if you hold it back, they're going to be very, very incentivized to make sure that they get it done on time and in sequence. The other way you can go is go completely opposite way and say, we'll pay you your base contract, but we'll incentivize you to the project goals and the delivery of AWP by providing a bonus. We'll give you an extra 5%, whatever it is, of the engineering contract value, scaled to their ability to meet the project goals, deliver the engineering on time, deliver it in sequence, support construction, etc. So as the owner, again, as the primary contract holder, you have ways to influence this with some incentivizing. And then again, the last thing from the owner or the sort of EPC standpoint, make sure you understand the value of early construction influence. Having construction in the room early is a key takeaway, but you need to make sure you bring them in. You need to have a budget there. Identify them, put them in your org chart. Don't just expect that they're going to be able to do this during the detailed design stages.
So key takeaways from an engineering perspective. First, AWP is a journey. So there are 4 levels of AWP maturity in engineering that we heard about today: the status quo, which is throwing the drawings over the fence, supporting workplace planning, which is additional engineering model attribution and providing additional data for automation, supporting basic AWP, which now you're starting to align that path of engineering with the path of construction. You're doing engineering work packages, you have some constraint management. And then when you move into supporting full AWP, which is engineering getting direct value out of AWP by leveraging level 4 planning, design work packages, vendor work packages, better review of vendor documentation, better constraint management, agile project management. It is a journey, and you should think of those as steps, and wherever you are, you should have a plan to move up those levels. Training is important. You need to include AWP training so engineers understand that AWP isn't going to turn their entire world upside down. You have to focus on how much of it doesn't change, but you need to include training into this process. So when you're trying to make any type of change like this, one of the biggest challenges to the change management is the lack of understanding. So that training is a really important piece. And then there is a way for engineering to directly benefit from AWP. AWP is not just about construction. AWP can be a significant benefit to engineering, regardless of whether you're doing workplace planning and field execution. There's a value to using AWP in engineering, and that's a really important takeaway. And that's one of the things that our CI group is focused on further defining. So further defining these levels of AWP maturity, getting a CII research process around this, and further identifying benefits and outcomes. So if you're interested in participating in that, please send me an email, josh@o3.solutions. Love to have more people on our group for that. It is important that we have a good representation of owners and EPCs and AWP experts and others on that committee. So please do reach out if you're interested in participating. With that, we do want to move into the live Q&A section of our presentation. So if you haven't had a chance to log into Slido, please do so. You can scan the QR code in front of you, or you can go to slido.com and join with O3 Engi, where you can enter all of your questions. So please take a second to join Slido, and then we will be switching the view over to Steve here to show the Slido questions, and then we should have the ability to respond to some of those. So, okay, looks like those are up and available. So first one up top is what are examples of incentives for engineers? Andrew, you talked a little bit about this on some of you can have categories of both positive and negative. One of the things that we've talked about on the contractor side is this idea of linking payments to successful package completion. So moving away from pure earned value quantities-based payments and moving into actually, you have to close out that IWP, and that has to be field inspected for that to qualify, and then you earn credit as package closing. Are there similar ways that you can do those types of incentives within the engineering approach, or what are some more ideas around incentives for engineers?
Yeah, absolutely. I mean, engineering can be paid in the exact same way as construction, where instead of just a drawing count and an overall percentage, you're getting paid for delivering the work that you're supposed to be delivering. So you don't, frankly, you don't get paid for delivering stuff that we don't need 6 months from now. You're getting paid for delivering the EWPs, the engineering that we need, and the sequence that we need it. And again, you can do that either as an entire amount of progress payment or as a percentage. For example, a lot of times engineering contractors will be paid their cost, and then the fee is the thing that's held at risk based on that schedule completion and the timing of completion of incentives. So everything can be quantified, everything can be based off here's what we should be and here's where we actually are. And owners should be able to find very, very good ways to be able to tie that. And don't throw this at the engineers and say, here's what we're doing. Sit down with the engineers and have this conversation. Explain, here's what we want to do. Here's how we're going to try to reward you or keep you incentivized to doing this in a sequence, and have the discussion with them. It's a very, very powerful tool to bring it up at the beginning of the conversation so they understand why it's being done.
Yeah, and this ties into a later question, but this is another area that the CII group is looking to further research and extend. So part of what we're trying to do, and I'll just go ahead and answer this, is one below that says, what's the CII group for AWP working on? And I'll just go ahead and address that. So one is to further define what you've seen today from in terms of levels of benefit, levels of AWP maturity, the investments in those, the outcomes. We want to try to tie those into a maturity model. We want to tie those into ROI models. We want to tie those into other tools for assessment. Right, so there's a set of tools that we want to build around this. We start with the definition of levels of maturity, and then once you have those, you can leverage those to help people understand, let me assess and see what level of maturity am I at. Then you can do things like, let me understand what ROI I could expect if I moved from one level to the next, right? What would be required to move to those levels? So there's a bunch of tools that the CII can help provide to facilitate some of those increase in adoption and maturity within organizations. So that ultimately is the goal of the CII group, is to make it easier for people to understand what the levels are, and then build a set of tools to make it easier for them to advance the level of maturities within their own organizations. So next question, how can I get sample data requirements for engineering? There are some CII sample data requirements. O3 as an organization, whenever we engage with our clients, we have a set of data requirements that we provide for our clients. There are industry examples at CII that you can have access to if you are a CII member. But from an O3 perspective, we do a more specific set around what O3 needs. And obviously, the CII set today, the documentation within CII is a little bit behind where engineering is from practical applications of AWP. So our data set goes a little bit beyond that to think about things like design work packages and vendor work packages, and additional kind of AWP maturity requirements that go beyond CII. But there are engineering data sets that you can leverage and are valuable at CII that I recommend. But when working with O3, we've got a set that we provide as part of that implementation process. Next question, consider DWPs to be a subset of EWPs. EWPs typically consist of IFC documents, while DWPs don't. We consider DWPs more as a predecessor. Please elaborate. Yeah, so that's a great question. So this comes down to when you define your EWP buckets, right? So if you define your EWP buckets much earlier in the project and you say, hey, I don't have everything defined inside this, but I've got these buckets similar to how I have early creation of CWPs when I'm doing early path of construction. Those haven't been fully elaborated. I don't understand everything that's inside that, but I have those holders, those buckets. I have a framework of AWP entities, and those will become more detailed over time. So if you define those EWP buckets early, then the DWPs can be a follow-on subset of those that then support that EWP. If you don't define those EWPs until later, then the DWPs may be a predecessor into an EWP that is done. We see the ideal best practice of defining your framework early on, both EWPs and CWPs, very early on in the process. And the earlier that you can define that AWP framework and load that into your AWP master index, the better it is for the project for setting it up for AWP success.
And I think it's important to consider on that one, Josh, as well. This is exactly the kind of detail that this engineering working group is looking to confirm with on behalf of CII is what is the best practice, what is the best way of doing it, and standardize that, much like they did with AWP years ago. They take the best practices in the way that everybody is currently doing things and solidify that into a standardized, repeatable process that'll have a much more better granularity over the relationship with the DWPs to the EWPs. So for the person asking the question, my first answer would be, we encourage you to join in and help provide your insight and input into how that process works.
Yeah, absolutely. Next question, who owns the technology for AWP and engineering? The owner, EPC, or EP? Andrew, you have thoughts on that?
Yeah, and to be perfectly honest with you, the answer can be anybody, but I think it goes back to the scale of maturity that we were talking about here. I think for anybody that's in levels 0 and 1, it's typically going to be the owner that owns that technology and is kind of pushing it onto the engineering contractor, because the engineering contractor in those stages isn't really doing it because they want to do it. They're doing it typically because they know it's got to be done, or they're being asked to do it contractually. Once you get into levels 2 and 3, where you're going to start to see that better benefit for engineering, and you're going to see the more AWP mature engineering contractors, you're much more likely to be able to see the engineering contractor pulling it in and operating it for their own benefit, and then being able to transition that data and information to the field. So again, it comes down to the timing, the maturity, and the contracting style that's being used, but there's no hard and fast answer to that.
And I think we've seen that play out in O3's own client base, where an owner may be using the tool and requiring it on projects, and then some of the EP firms and C contractors get exposure, and then now on subsequent projects, they've purchased the tool and are leveraging it themselves. So we have seen that play out in our client base as well, in addition to sort of thinking about it from a maturity perspective. Okay, are engineers really using AWP for their own benefit? The answer to that is yes, but we are in early stages of this. This is why we're pushing this from a CII perspective. There are engineers using AWP for their own benefit, and it's not just limited to, this is larger than just what O3 is doing. There are engineering firms that are implementing AWP principles. There are engineering firms that are leveraging agile project management to better scope and leverage sprints to be more efficient. So there are definitely organizations that are doing this, and O3, in our process of identifying that this was an issue, we went to folks that we thought might be either doing this or interested in doing this, and we partnered with a number of engineering firms that are AWP mature that were already doing portions of this, as well as owner engineer organizations that have the ability to influence and drive change within their organization a little bit more than maybe some organizations do, to partner and develop our approach to this. So from an O3 perspective, we found folks that were already doing this or doing parts of this to partner with to develop our solution. So the short answer is yes, but it's definitely leaders in the space. But we want to define this and get this locked in so that we can move beyond the thought leaders and get more and more organizations leveraging AWP and engineering and seeing the benefits, because we want to advance the industry and move it forward. So let's see, we talked about the second one there. As an owner, how can I really know whether the engineers on my job are using AWP principles? All right, Andrew, what do you think about this?
So the first place I would point anybody here is CII has a tool called the Maturity Level Benefits tool. And one of the things that we developed for that tool was a set of key performance indicators, which are broken into two areas. One that talks about AWP adoption. Are we really doing AWP rather than just talking about it? So methodologies for assessing, like you say, whether those engineers are actually performing AWP. And then there's a second set of KPIs that looks at the benefits. What value are we getting out of doing AWP in this job? So all I would say is the first place to look is if you go onto that CII landing page for AWP and find that maturity level benefits tool, it'll point you at some very, very good KPIs. There's also a webinar that we did, that O3 did back in June, July, that's available on our website that talks about the top 14 key performance indicators for engineering and construction. So the first half dozen of those look at the engineering stages, and that can be very good value for you. So just look at the resources page on our website.
Yeah, absolutely. So really enjoy everyone's time today, and thank you so much for listening in. If you are interested in participating in this conversation, either from a CII perspective, please reach out to me, or your organization is interested in furthering the AWP maturity and leveraging technology, then O3 would love to talk to you as well and share some of what we've seen with some of our other partners in this space. So thank you everyone for your time, and I hope that you learned something here today. We really appreciated the questions and engagement, and look forward to chatting with everyone again soon.
Thank you, Josh. Thanks, Andrew, and thanks everyone for joining in again. Watch your inbox for a recording of this session, as well as invitations to future free webinars from the AWP Community of Practice. Have a great day and stay safe. Bye now.